operators when we count down 1. Flight directors go for launch. Ignition. Stage separation. Booster light burn separation.
Hello and welcome to Starbase, Texas. It's 5:19 p.m. Texas time, and we are just over 31 and a half minutes away from Starship Flight 13, the second test flight of our next generation Starship, version 3. During our initial launch attempt last week, we had a clean countdown, loaded all propellant, and got all the way to engine ignition, where the vehicle executed a safe shutdown when its automated systems detected off-nominal startup on 4 engines. That safe shutdown ensured that both the vehicle and launch pad were kept safe. As we often say, the payload on these test flights is data, and even when we don't get off the ground, we learn some valuable lessons and improve from them. We're going to dig into the details of that in just a moment, but all of that to say is that we're here today and we're ready for our second launch attempt. I'm Kate Tice, Senior Manager of Quality Systems Engineering.
And I'm Nathan Commissariat, a civil engineer here at SpaceX. Today, we're coming to you live once again from just outside the Star Factory production floor, about 1.5 miles from the rocket on the pad.
Back in May, the first test flight of Starship version 3 delivered tons of data, and we'll be putting those learnings into practice today on Flight 2. All of this brings us one step closer to a fully and rapidly reusable vehicle, the key to enabling frequent flights to the Moon and Mars. Starship will also enhance Starlink's constellation and connectivity on Earth, the Moon, and beyond, while helping establish a network of AI data centers in space. Success on today's suborbital mission also opens the door for near-future orbital flights and our first attempt to catch ship on Tower 2 here at Starbase.
And this is an exciting day for the Starlink team as well, as we're planning to deploy 20 of the newest generation Starlink satellites. These sats aren't intended for operational use and will only be in space for about 20 minutes before demising. But during those 20 minutes, we're going to attempt to speedrun a bunch of tests. Things like deploying solar arrays, firing thrusters. We'll get into those a little bit later into the show.
Yeah, and what Starlink engineers learned today will be essential to deploying operational V3 satellites into the Starlink constellation on future Starship flights. These larger, more powerful next-generation satellites are designed to boost orbital capacity, strengthen the overall network, and deliver a noticeably better experience for our customers.
And as we've said before, Starship is a developmental program. What we're doing today is a test. We test in flight because it's the best way to rapidly iterate the design, and it's the best way to put the vehicle through its paces in the actual conditions it will experience during an operational mission.
Yeah, exactly. So while we have real Starlink satellites on board, the most important payload today is data. But no matter the outcome of today's test flight, excitement is once again guaranteed.
Now let's head a couple of floors upstairs where Dan Hewitt is just outside the Launch Control Center. How's it going, Dan?
Hey, Nate. It is going great. Hi to you and Kate. Hello, everybody else. I'm Dan Hewitt with SpaceX Communications. Happy to be here with you for another launch day. As Kate noted, our first attempt to launch this flight test last Thursday ended early in a pad abort. Let's dig into that a little bit. So 4 of Super Heavy's 33 Raptor engines aborted at startup due to issues with their aux turbo pumps. Those rapidly pressurize and feed liquid oxygen into the engine for combustion. For those of you that like to pay real close attention to the on-screen telemetry, you saw this at T0 during that first attempt. We command the engines to start up simultaneously. You get some slight differences as the engine adapts in real time, but you saw 4 not light up. So 4 out of 33, what exactly happened? We have a launch constraint built in where we can only be down 2 Raptor engines at liftoff. So the vehicle detected more than that, we're out. automatically aborted before the final T0 safely shut down all of the engines that started up. We dug through the data, and what we saw was some off-nominal spin response in the aux turbo pumps on 6 of the engines. So the most likely root cause was determined. We were collecting some moisture inside of the pumps from previous operations, which then froze when we introduced that cryogenic propellant, and that either slowed those pumps down or stopped them completely from spinning. So for this next flight attempt, we swapped in 6 engines that were already at Starbase, and we did a test back on Wednesday that allowed us to check out the newly installed engines and spin the aux pumps on all 33 after they were chilled, check out their performance before we got into another launch attempt. We pulled a bunch of those engines off, as we said. We tested one on a test stand up at McGregor, helped screen for any other issues that might be hiding, and that one was actually able to do a full booster ascent burn. So got us in a good position for today. Even though we didn't get off the pad last week, we learned about the engines, the prop systems, how they perform in the flight environment. Already going to drive some changes to make Starship more reliable. We also got a real-world test of an abort that's designed to take place at one of the most critical dynamic phases of flight. We safely shut down 29 running Raptor engines, safeguarded the vehicle and the pad. A mountain of work goes into designing aborts. You've got software, hardware engineers just dreaming up bad day scenarios, how we want the vehicle to respond, just to give us the best possible path to maximize safety, preserve the mission and the hardware, so we're able to do that. All right, that was then. This is now Flight 13's second attempt. So things are looking really good at the moment. Just behind me here is the Launch Control Center. Everybody's on console, looking at the systems on board the vehicle and on the pad as we count down to liftoff. Propellant load is underway. We slipped a little bit into our window as we waited for some last couple of things to settle out, and we are targeting a liftoff at 5:51 p.m. Central Time. Weather today, you can see we've got blue skies. We're going to do a little weather corner here for a second because we were originally attempting to fly yesterday, and we didn't because of, we said, weather. I want to be clear, the cause of not flying was visibility. It had nothing to do with launch weather constraints. One of the key goals of this flight is to get very clear imagery of the tiles on Starship as we're flying it at a higher dynamic pressure. You can't do that when you have clouds completely obscuring your view through all of those critical phases of ascent. We're actually capable and legally allowed to launch into lightning because we've done a ton of testing, unique testing, analysis, studying aircraft capabilities, and it's designed because that's ultimately the cadence we want to fly at, like an airplane. We're going to utilize that new capability carefully, but we're very aware if we want to fly Starship as often as you could fly an airplane, you're going to have to fly in weather that historically would keep rockets on the ground. So we're doing that analysis, we're doing that testing to prepare for the future. Aside from weather, we're watching the range, both in the Gulf right here off Starbase and in the Indian Ocean. That's currently green. We are not tracking any vehicle or pad issues that will preclude a launch today. Speaking of the pad, that launch infrastructure, it's every bit as complicated as the rocket itself. It's designed to operate in some of the most extreme conditions on Earth. In case you missed it, we had some pretty cool insight into what it takes to launch the most powerful rocket on the planet in the second episode of our ongoing documentary, Starship.
When we're only a week out from flight, my main focus is getting into flight. The thing that separates us from a lot of other companies is that we test fast and we test often, and that includes launches. We want to make sure the vehicle's all ready to go, we want to make sure the ground's all ready to go, but we also don't want to be caught in analysis paralysis.
Our main objective today is a 10-engine static fire. Aboard. One LVN-1 looks like we kicked out due to 2 combustors from the apex being pelted.
There was a pad side abort called. These things were holding like 5,000–6,000 tons of propellant plus the rocket weight. And it's like, okay, well, why didn't you guys simulate that? It's like, well, because we didn't have anything that weighed that much. Like, this is the first time we put anything on it that weighed that much. So there's just so much that you have to think about and be very paranoid on.
We kicked out early. All teams triage alerts, prepare for offload.
We actually had another pad abort on the diverter.
Basically, right during engine firing, it was so much noise and vibration that it actually shook the sensors that are located out in this area enough that they aborted us out of the test. We went back, obviously, afterwards and looked at all the data and tried to come up with smarter ways to basically still protect the integrity of the diverter throughout the operation while changing our parameters so that we were making sure that we would not abort again.
A flame diverter is like a super simple concept that is like not at all complicated in operation and is just absolutely murderous in the details. These are extremely sophisticated thermal load sensing devices. If they turn into melted metal slag, then you know that you got too much heat. If you melt this, you're hotter than aluminum melts. If you melt this, you're hotter than zinc melts. If you melt this, you're hotter than copper melts. If you melt this, you're hotter than Sharpie melts. So we're sub-Sharpie. We have all of this mass flow, all of this energy that is just absolutely trying to obliterate our pad. We want to give it a thing to obliterate to keep from obliterating the things that we care about. And the thing we give it is water. The amount of energy that water can absorb is like miraculous. And so if you can get high enough pressure water in the right places and just allow it to flash boil that water, then it solves a lot of the problems for you. Like the idea is that the steel never gets that hot, the structures never get that hot, because the water absorbs all that energy, turns to steam, and everything's okay.
So for this flame deflector on pad 2, we're sitting somewhere in the neighborhood of about 650,000 gallons per minute. That's approximately in the range of about like one entire Olympic swimming pool being drained in the course of a minute.
You're trying to look into this thing and you see how like glowing hot it is. It's just yeah, a pretty impossible environment to keep something happy in. But and you zoom in and the flame deflector's still there, so that's the reason we build those things.
Putting the rocket into human terms is something really tough. 65,000 pounds per second of propellant that is coming out of the engines. And again, just like 18 million pounds of thrust, like what does that number mean? I think of like 11 Ford F-150 trucks per second just zipping out of the bottom of the rocket. It's like imagine if you had the world's biggest machine gun, except for instead of shooting bullets, it was shooting pickup trucks, and it's just firing 11 pickup trucks per second out of the bottom of the rocket. It's like, do you think your stuff could survive that?
And it is so satisfying to watch the slow motion flame diverter shots.
Right, and just hear all the exciting stories of how we tackle these problems out here in Starbase. Super exciting.
Yeah. And by the way, if that looks like fun to you, come join our team. We are seeking scrappy problem solvers to help us build the future. Okay, let's go meet the rocket out on the pad, Starship version 3. It's the most powerful rocket ever developed and ever flown.
And it's also the tallest at just over 407 feet tall, fully stacked. It is massive. Standing at the base and looking up is like looking up at a 40-story building. Incredible.
Yes, it's a two-stage rocket. Both stages are designed to return to Earth and fly again, making that thing that you see on your screen the first fully reusable rocket ever. The bottom half, or the first stage, is the Super Heavy booster. That's the silver part. It's powered by 33 of our newest iteration, you see them there on your screen now, Raptor 3 engines. They run on liquid methane and oxygen, and this version of Raptor provides a significant increase in thrust. With that additional thrust, as you can see here by these comparisons, the version that we're launching today, version 3 on the far right, that version of Starship gets off the pad much faster than our previous versions. The one on the far left I believe is actually our Flight 1 footage, and in comparison, they really just go.
Yep. And now Super Heavy has 3 grid fins, which you can think of as aerodynamic rudders. You see them on your screen now. They help steer during landing. They're 50% larger than on previous booster versions and are designed to support rapid reuse and a more stable atmospheric reentry.
I love that shot there. And at the top of the booster, we've got the hot stage adapter. It's designed to protect the booster during separation, and now it's fully integrated for reusability.
And stacked right above that is our upper stage of the rocket, or stage 2. It's what we call ship. It's powered by 6 Raptor engines, 3 optimized to sea level performance, and 3 for the vacuum of space.
Ship's design could one day enable point-to-point transfer on Earth, meaning you could travel anywhere on the planet in an hour or less. Sounds pretty great to me.
Sounds awesome.
It's designed to carry massive orbital payloads, both cargo and crew, to Earth orbit, the moon, Mars, and beyond.
And for the first time, we are carrying real Starlink V3 satellites to space. For more on that, let's head out to California, where Tyler is standing by with the team in Hawthorne. How's it going, Tyler?
We're doing great over here, Nate. Thank you both. I'm Tyler Lionquist, and I'm a Starlink business analyst here at SpaceX. Now, for those of you who have been following along, the Starlink version 3 satellites have been designed to take full advantage of Starship's payload capacity. And we're going to get our first look at those satellites today. The Starlink V3 is our next-gen satellite, and it includes meaningful increases in capacity, data density, and power generation. So we'll be adding around 20 times the capacity into the constellation on each Starship mission as compared to the version 2 satellites that we launch on Falcon. And that means that we'll be able to serve more people all around the world and with increasingly better high-speed internet. Like all Starlink satellites, the V3s are built at Starlink's site in Redmond, Washington, where we already build more satellites than anyone else in the world today. Now, the V3 sats are designed to support 1 terabit per second of downlink and 160 gigabits per second of uplink capacity. That's approximately a 10 times improvement in downlink capacity and around a 22 times increase in uplink capacity from the version 2 Starlink satellite. Serving this capacity to and from customers are the satellite's upgraded phased array antennas. The upgraded phased arrays are fed by SpaceX's in-house developed chips that were designed to serve customers more efficiently in both densely and sparsely populated regions simultaneously. And each Starlink V3 satellite is also equipped with 6 high-capacity 400 gigabit space lasers. Now, these 6 lasers will allow high-bandwidth traffic to flow uninterrupted between any 2 points in the world with redundant paths across a petabit laser mesh network. And if that wasn't enough, the V3s will carry 4 quad-band radio frequency backhaul antennas. And these will take advantage of the Ka, E, V, and W communication bands, allowing for an 8 times improvement in supported capacity compared to the V2 sats. And that's a lot of growth in capacity and capability. And as such, the new satellite design requires more power. So the solar arrays on V3 will generate approximately twice as much power as the current arrays that we fly on the V2 satellites. And they're also optimized to reduce drag in the lower orbital altitudes in which these new satellites will operate. But before we operationalize these satellites, we want to put them in a flight-like environment. These satellites were loaded into Starship last week ahead of that first attempt. And once deployed, the Starlink team will only have about 20 minutes of flight to speed run some of these tests before the sat's demise in the atmosphere. The team will attempt to run tests such as extending the new solar arrays and antennas, connecting with ground stations, and turning on the satellite's communication systems. And this is all part of SpaceX's iterative process to technology advancement. From the very beginning, Starlink was designed to scale rapidly and improve continuously. From production to launch and ground infrastructure, Starlink is uniquely positioned to keep pace with rising demand around the world. In fact, just last week, we rolled out the next generation Starlink kit, the V5, which is built for reliable, high-speed home internet.
All right, you heard from Tyler. A lot of work going on with Starlink. We've also started development on an entirely new satellite constellation, StarMind, our AI satellites. I got to sit down with Elon and Starlink's Director of Satellite Engineering, Ian Dahl. We covered a whole bunch of stuff, really focused on what are the 3 limiting factors to making data centers in space a reality. First one we talked about was mass to orbit. That's where Starship comes in. We're going to need megatons into low Earth orbit, and we're going to be combining its full reusability and the really big payload capacity to launch the number of satellites that we're talking about, because we plan to deploy up to 1 million AI satellites, and those are going to function as those orbital data centers using Starship for the high volume, low cost launches. A couple of really key reasons why moving data centers to space has advantages over building them here on Earth, which gets into our second limiting factor, which is power generation. It's always sunny in space. Satellites can harness that sun, that near constant solar energy, which is really going to be the only way to scale if AI continues to grow at the pace that we see, especially when you contrast it with all of the challenges that you have here on Earth. Within about 2 to 3 years, we believe space-based AI compute is going to become the lowest cost option as those launch costs continue to drop and Earth-based constraints continue to grow. It's going to just transform how Earth powers AI, unlocks the future. And then our third limiting factor that we got to go figure out is going to be chips, and we got to do that fast. And that's what we're doing with TerraFab. That's going to be the most epic chip building effort ever. Not just churning out really cool advanced chips, but also building a massive scale location to do it. We're talking 100 million square feet, so about 10 Tesla gigafactories. All of this together sounds a bit fantastical, a bit out there, but these are real steps that we are taking right now that are going to set us up to eventually become a galactic civilization. That sounds really cool. I mean, harnessing meaningful amounts of power from the sun, supporting all of those AI applications that are going to change our daily lives, and making humanity a multi-planetary species. If you want to learn more, you can watch the full conversation on our website. Hopefully a link appears on the screen. If not, go look up StarMind. So the future is looking pretty sweet, but first things first, we've got Flight 13 ahead. Let's jump down to Kate and Nate for what's ahead.
Thanks, Dan. Yeah, the future is built on progressive steps like today's test. So let's dive into the flight profile that we're going to see today.
That's right. We've got an exciting day in store. So starting with liftoff, Super Heavy will ignite those 33 Raptor 3 engines right off of Pad 2 here in Starbase. We will then power through ascent ahead of hot stage separation, where the booster will shut down all but 5 engines at the bottom. Stage 2 will then light its own Raptor engines, pushing off from Super Heavy and starting our stage separation maneuver known as hot staging. We will then have the directional booster flip using 33 engines, and after coasting for a few minutes, the booster today will target a landing burn and ocean splashdown a few miles off the coast of Starbase.
Ship is going to keep the party going with its ascent burn to a suborbital trajectory, followed by deployment of those 20 Starlink V3 satellites. We also plan to relight a single Raptor engine. Re-entry is just a few minutes later, which should provide some amazing views thanks to Starlink. And typically we see some pretty fantastic views of the ship's blistering re-entry through the Earth's atmosphere. A plasma blanket will form around the vehicle and never prevails to provide epic scenes. And lastly, we'll conclude today's test with a landing flip, a landing burn, and a splashdown in the Indian Ocean. And with that, let's kick it over to Dan for a countdown update.
Thanks, Kate. Good news. We just heard from the flight director. We are T-minus 10 minutes. We're a little bit past that now, not tracking any issues for launch today. Range continues to be green. Our range team hard at work, making sure we're clear out in the Gulf and in the Indian Ocean, where we're going to be sending the Starship. Weather continues to be gorgeous. Again, no clouds. We scrubbed our attempt yesterday, or didn't even try yesterday, because we had such poor visibility. Weren't going to be able to see those tiles on the way up. That's a key kind of experiment objective for this flight today. And so we're looking really good with weather today. In the future, we'll see what kind of adverse weather we can fly into. We are capable and allowed to launch into lightning, but we're going to utilize that new capability carefully as we eventually continue to evolve Starship to fly it at an airplane-like cadence. You can see the prop load there on your screen. We're just about closed out on the main tanks on the ship. We just started propellant load in the header tanks on Starship. Those are the 2 smaller ones up top that we'll hopefully be using for the in-space burn and a landing burn at the end of its mission. We started loading our propellant at about T-minus 35 minutes today, and we're going to continue all the way down until we're inside 3 minutes to launch. We'll close out at about T-minus 2 minutes and 50 seconds on booster, and then 2 minutes and 10 seconds on the ship. So at the moment, we're looking good. That launch time, 5:51 p.m. Central, a couple of minutes into our window today. So we'll be back real soon. Toss it back down to Kate and Nate.
Thanks, Dan. Recently, NASA announced the astronauts for the upcoming Artemis 3 mission. The Artemis 3 mission is a crewed demonstration mission in low Earth orbit designed to demonstrate critical systems needed for future lunar landings. Astronauts Andre Douglas, Luca Parmitano, Randy Bresnik, and Frank Rubio, as seen there on your screen, they will crew the mission, and it's slated for 2027.
It's a great crew, and it's also the penultimate mission, the final test before Artemis 4 attempts to put astronaut boots back on the moon for the first time since 1972. We'll be launching a Starship with a docking port on the nose so we can practice rendezvous and docking with the crew. And one key test objective comes after docking, where we will be able to test out maneuverability of the vehicles together while in space. This has the new importance as the revamped plan for lunar landings use Starship to do the burn, sending astronauts to the moon from Earth orbit.
And one other cool ad, NASA is putting 2 SpaceX mini lasers on Orion to connect it to our Starlink constellation with the goal of enabling 4K imagery and video from the spacecraft while in space. So that's going to be pretty awesome to see.
Awesome views for sure.
Yeah, there's lots of excitement planned for next year as we all work together to send humans back to the moon. And speaking of sending humans to space, former SpaceXer and current NASA astronaut Anil Menon is actually up on the space station right now as part of Expedition 74. And he captured these sweet photos of Starbase during an ISS flyover. Hi, Anil. We're all waving back at you, buddy. It's awesome to see the whole picture here as there's lots of facility and infrastructure development going on. But Starbase isn't alone on that front.
Yeah, it changes every day.
Yeah.
But talking about other locations, work is well underway in Florida to get pads 39A and Slick 37A ready for future Starship launches potentially later this year. Starship launches from Cape Canaveral are key to hit the necessary launch cadence to get back to the moon, build a moon base, head to Mars, all the exciting stuff ahead in the future.
Yeah, exactly. And that future gets closer and closer with tests like today's flight. And with that, we are just under 6 minutes until launch. So that brings us to terminal count. Excitement is definitely gaining traction down here as the crowd is gathering just behind us on the lawn outside, and happy to say, still not a cloud in the sky. Dan, how are things up at Mission Control?
Things are still looking really good, Kate. We are still not tracking any holds on the board, no issues with the vehicle or with the pad. Our range continues to be green, both in the Gulf and out in the Indian Ocean for flight today. We'll continue monitoring that all the way down to the final minutes. We are going to be closing out our propellant loading on the booster and the ship within the next 3 minutes. We're going to have about 11.5 million pounds of liquid oxygen and liquid methane on both of those stages once we're all done. Then it'll be time for the pad to essentially ready itself, where we clear out all of the prop that's been flowing through feed lines up into the launch mount, up into the tower. Those go back into the propellant farm, get it ready, and we'll do those final thrust vector control, those steering checks as we get a little bit closer. If we need to hold that hold time, it's new for this launch, and we saw it briefly on our attempt last week. That hold is set at T-minus 60 seconds now. That's where we can pause, we can wait. If we need to just kind of hang out for any pressurizations, anything like that to clear, we've got a couple of minutes to hang there. We will only hold if there's an issue, and we're not tracking any holds on the board right now.
That's right. Now, once T-minus 60 seconds passes, a number of events will occur in rapid succession. Both the ship and booster will configure their comm systems for flight, and they will rapidly run leak checks on gas and fluid tanks. Meanwhile, the booster will be going into internal power, and its engines will get their final priming for launch. Those ship engines will also begin their ascent bleed profile, and it will arm its automatic flight safety system. There's a lot of mechanical activations on the tower side as well, with one critical step being unlatching of the quick disconnect, feeding propellant into the ship.
And once T-minus 60 seconds has passed, we still have the ability to rapidly recycle the count under certain conditions back to that T-minus 60 seconds point and hold there to assess what happened and if teams can proceed once again to T0. There's an estimated 5 to 8 minutes of hold time, and that's largely driven by the propellant temperatures that we see on the vehicle while holding. The flame diverter on pad 2, you can see it there at the base of Starship. That activates at T-minus 17 seconds. Now, if we trigger a hold after T-minus 17 seconds, that will result in a scrub for the day, as we've already turned on the water. Now, for those that have just recently tuned in, once again, our primary test objectives for today's test flight includes a successful liftoff, stage separation. We also plan to deploy 20 Starlink V3 satellites. We have real satellites on board. We expect to have about 20 minutes of available time to speed run some tests and really allow the Starlink engineers to put them to the test in that time.
That's right, and we also have the soft splashdowns planned for both the booster and the ship. Going to be super exciting to see if we can return those safely back, so that way we can get ready for tower catches again.
And just a quick check-in, we got our final green light from the range, not tracking any issues on ascent or out in the Indian Ocean for entry, so that was kind of the final go for flight that we wait for in these final minutes. Prop load now closing out on both vehicles. We have no holds on the board. Again, we've got that gate at T-minus 1 minute. We're only going to hold if there's a reason, and currently there are no reasons.
Now, coming up here in a few seconds, we should have, actually right there we can see on screen, that's the base of the Super Heavy booster. Those are the 33 Raptor engines, and we expect to see and there they go, the TVC checkouts, also known as engine wiggles. We're activating those thrust vector control actuators to ensure that those center engines and the inner radius as well have the ability to steer the rocket.
Yep, super cool to see how fast those move. I mean, in flight, it's amazing to see how it steers the vehicle. And we're coming up on that T-minus 1 minute now on our countdown, so let's listen in to see if we pass that gate.
All right, we are through the gate. Still no holds on the board. 50 seconds to go. Starship getting ready to fly.
Flight tractors go for launch. -9, 8, 7, 6, 5, 4, 3, 2, 1. Lift off Starship.
Vehicle is pitching downrange. Booster Raptor chamber pressure is nominal.
Seconds into flight, 33 out of 33 Raptor engines lit on the Super Heavy booster, arcing away from us here at Starbase. Coming up on max Q, maximum aerodynamic pressure, which again for this flight is going to be higher than it has been on any of our previous Starship flights. Right, so we're passing through that maximum aerodynamic pressure over a minute now into flight. Still seeing 33 out of 33 Raptor engines lit and burning. Our next major moment's going to be coming up in just a little over a minute from now when we're going to get to hot staging. We're going to shut down all but 5 of those engines on the booster. It's our version of MECO. Most engines cut off. And then we're going to ignite the 6 engines on the ship while it is still attached, to do that separation. As a reminder, we try to do a directional flip, so When you watch on your screen, we're hopefully going to be sending that booster towards the bottom of the frame. For the booster itself, it's like doing a flip up. It'll go towards the bottom of your frame. We do that by lighting the engines in a slightly staggered sequence. Standing by for hot staging. All but 5 engines down.
Cutoff. Accept.
6 ignite.
Blackburn startup.
And the booster now doing its boost back burn. It looks like we lit all 33 initially. Now we're down to 13. We're seeing 6 out of 6 Raptors lit on the ship.
Backburn shut down.
And boost back burn shut down. So it looks like we were able to get through the boost back burn this time around. That was one of the key objectives we didn't have on the last flight.
Nominal.
And we've got 6 engines lit on the ship. All right, so that's the first of 2 burns that the booster is going to be doing to kind of send it back towards us. It's going to be landing a couple of miles offshore from Starbase, hopefully. We're going to try and get it all the way down to do a landing burn, where we're going to use those 13 center engines. They're going to ignite. That's what's going to really bleed off all that velocity that it's built up. And it'll eventually, hopefully, transition to 5 engines to kind of fine-tune its path in, and then all the way down to 3 for the remaining bit. All right, we've got a couple of minutes to go until we get there. So booster's going to coast for a little bit. Ship still seeing 6 out of 6 Raptor engines lit. 4 minutes into the flight. Ship's got about 4 minutes left. Getting some killer views. Kate, Nate, how was the view from from down there?
It was incredible. I mean, it just shot off the pad, and seeing all the crowd now running back inside to take views on the screen here, it was amazing.
Yeah, one of these days I'm gonna learn to not stare at the engines, because now I have a bright blob in my vision.
Right.
Now, speaking of vision, we could see both stages there on your screen. Starship's second stage is still firing its engines. You can follow along with that with the GUI down on the bottom right-hand side of your screen. Still following the planned flight path as well. Beautiful views of planet Earth there behind the ship.
That's right, and we're actually getting a live shot off the booster right now, an onboard camera. You can see the plume from Starbase where it just lifted off 5 minutes ago.
On nominal trajectory.
We are there.
We are there. That is us.
I kind of want to run back outside and wave.
Right. Now, again, this booster is not planning to come back to the tower or the launch site for this particular launch. We are going to be planning to do an ocean splashdown just off the coast of Starbase, so hoping to still get some amazing views of that.
Pretty awesome to see the Raptor engines there on the left-hand side of your screen. We can actually see the plume there of those center Raptors. Those are the sea level ones, as well as the vacuum Raptors are the 3 on the larger ones on the outer radius.
Now, just like on tower catches, we are going to be doing a 13-engine landing burn to slow the booster down. Hopefully we can get a live camera of the booster right now as we're going into that phase. Awesome shot, you can see it there. So right now the booster is using their 3 hypersonic grid fins to guide itself through the atmosphere toward its landing site. You can see we're only 5 kilometers above the sea right here.
Startup.
Just heard the call out for landing burn startup for the booster. I have a feeling the crowd's about to go wild here.
And another awesome landing for Super Heavy. Congratulations to all the teams here at Starbase and at our SpaceX team. An amazing, amazing view.
Everything continues to go well with ship, as you can see there on your screen.
Yeah, we've got about a minute left with the ship engines on. Just looking at the booster real quick, it didn't look like we lit all 13 engines that we were planning for that initial landing burn. We were targeting a softer splashdown, and as you saw, it came in with quite a bit of velocity still. So landing velocity did look a little bit high, but really cool to make it all the way back this time to that landing burn. We'll dig in, figure out how to turn on all those engines, and then get to a full landing soon. But all eyes on ship. We are just a little ways away from getting those engines turned off. We expect it to burn about 8 minutes and change. And so hopefully just about 15 minutes to go. Sounds like we just got the sonic boom
Yeah,
here
we sure
at
did.
Starbase
That was awesome.
from the booster splashdown. And engine shutdown. All right, Starship 6 Raptor engines have successfully shut down.
Nominal orbit insertion.
And there's our call out for nominal orbit insertion. So we got a ship in space. We've got a booster in the Gulf where we were planning to send it. It's a hell of a start to the day, Kate.
Yeah, it sure is. All of our colleagues here are filing in through the doors. A lot of people wanted to stay outside and hear the boom. And so it's pretty great to see a ship in space, and everybody's super excited down here.
That's right. And as guaranteed, it has been an awesome day so far. All this action in just 9 minutes now. And objectives are done for the booster. Just want to quickly flag that that booster did land in a clear zone. We clear those before launch, well ahead, so that we ensure everyone is safe before the launch and after. So we're getting ready now for our in-space objectives.
Yeah, we've got a few minutes until the next milestone, so sit tight and enjoy the space views and, of course, the space jams. We'll be back here at T+14 minutes to deploy our payload, which is 20 of our newest Starlink version 3 satellites. So we'll see you soon.
Ship FTS is saved.
Welcome back. If you're just joining us, we're getting ready to deploy 20 Starlink version 3 satellites. That will get underway after we open the payload door in just about a minute. Now, for those of you that perhaps missed the previous 14 minutes, this is the second flight of Starship version 3. This is flight 13. It lifted off. It had a beautiful ascent as well as a ship ignition and stage separation. It was literally picture perfect from here at Starbase.
Picture perfect, and then we continued with that booster hot stage separation. Amazing to see some live replays of that. And of course, the booster performing its own boost back and landing.
Yeah, ship continued for about 8 minutes with all 6 of its engines and made it to second engine cutoff, where we heard good orbital insertion, and we've been coasting in space for the last few minutes. Now we're getting ready to deploy our very first real Starlink version 3 satellites. The door will be opening here in just about 6 seconds from now. Now, we won't have the same views as we did on Flight 12 of our payload. We don't have those cameras on board these Starship version 3s. That was a Dodger Dog exclusive, but we will be able to see them deploy from the ship.
As Kate said, we should see the door open up really soon if we haven't quite gotten it open already. We've got 20 of these Starlink V3 satellites. Looks like the PEZ door is open. And so, yeah, this is the first time we've got Starlink V3 satellites getting ready to go into space. And I mean, these things are really just kind of crazy upgrades that they're going to bring to the network, where you start talking about just symmetric gigabit speeds through the Starlink network pretty much anywhere on the planet that this is going to unlock. So really exciting. These satellites are only going to be in space for about 20 minutes. Sorry about that. These will only be in space for about 20 minutes, as they're on the same suborbital trajectory as Starship itself. This is essentially just giving us a chance to try and run as many tests as possible, deploy the solar arrays, antennas, whatever we can on these vehicles. We are intentionally being a little scrappy with it. They might be playing some bumper cars once they're out of the door, but we are looking to get these deployed over the next couple of minutes. In the meantime, they're getting ready to also do the Raptor in-space relight. Listening to a little bit of conversation on that, but we are currently tracking to do it. I'll give you some updates if we hear otherwise.
And there you go. You can see our first Starlink V3 getting deployed out of Starship. Huge milestone for the team out here.
Yeah, the crowd is definitely hyped about this. We could see these Starlink V3s continuing to pop out with deployment assisted by the PEZ dispenser. Now, this version of Starship is built to deploy up to 60 of these more advanced Starlink version 3 satellites. Each V3 is designed to offer 1 terabit per second of downlink capacity. Now, let's put that into Falcon 9 terms real quick. A Starship launch with V3 satellites will launch 20 times the capacity into the constellation as a single launch of V2 satellites on Falcon 9. Just incredible.
And anybody that follows Starship, you know that the views that we're being treated to right now, the views we get during those re-entries, that's made possible by Starlink. It's given us just this unprecedented look into Starship as it's flying through space, hurtling through the atmosphere. It's powering the dozens of cameras we have on board. It's giving us real-time data on every system that's telemetered on board that vehicle in real time. We use the exact same constellation to power all of our cameras that we have out in the field here in the Indian Ocean. So really powerful technology for just connecting you no matter where the heck you are on the planet, off the planet. So thank you, Starlink, for letting me watch this stuff as we fly through space. It's pretty awesome. We get about 240 megabits per second of data rate off Starship, which everybody in the spaceflight community knows that's pretty insane when you're usually dealing with single digits on some of the older systems. So gives you a lot of insight, gives you a lot of ability to just rapidly iterate, know what the heck happened when things go wrong. But looks like we're seeing some more satellites get out the door. We do have cameras on some of them. The last couple that are going to go out are going to try and do the heat shield imaging that we attempted last flight. We don't have that camera view that we got on Flight 12 where you kind of see the satellite leaving Starship. Those aren't on the V3 satellites, but we are going to, on the last couple that go out, have some pretty narrow field view cameras that are going to be looking back at Starship, turn on some flashlights. And this is a test of a capability that we're really going to want when we start doing orbital flights, to just add that extra layer of safety, that extra layer of reliability, where we're going to be able to image Starship's heat shield after it's gone through ascent, after it's been in space, before it re-enters. So we're going to try to test that again today. The heat shield imaging, we didn't get a whole lot last time. Ooh, looks like we got some thunderstorms on planet Earth below us. But a couple more satellites to go, it looks like.
Yeah, it's pretty awesome to see our V3s in space. I want to give a shout out to our Starlink colleagues. And we expect payload deploy to run until about 27.5 minutes, so about another 7 minutes here. The Starlink team will be attempting to speed run these tests, or excuse me, speed run test these version 3 satellites, where they will attempt to do a few tests, such as extend the new solar arrays and antennas. They're also going to try and connect these V3 satellites with ground stations and turn on the satellite's communication systems. Now, they're only going to have about 20 minutes or so to do all of this, as these satellites only have that long before they demise in the atmosphere or break up due to that friction when they re-enter the atmosphere. So what we learn from today's deployment will help progress and move the program forward, which is super exciting. You could basically say that the payload's payload is data.
That's right.
We're getting very Inception here. Now, in addition to those tests for Starlink, for the Starlink team, as Dan mentioned, 6 of the satellites have been modified with engineering cameras to help scan Starship's heat shield. That will help inform our analysis of Starship's readiness for future catch returns back here at our launch site. So for those that might be unfamiliar, we are currently capable of catching our super heavy booster, and we've done that a couple of times. We have not yet attempted to catch our second stage or ship, and so that is going to be a very exciting milestone when that day comes.
For sure, and we're building up to it with today's tests. We are still planning to do our water splashdown in the Indian Ocean, so stay tuned for that. That's only about 40 minutes away. But still in space, we keep on deploying our Starlink satellites. Again, these are our V3 version of our Starlink satellites, a whole host of added capabilities to our version 2 that's currently in orbit.
And this is our team here at Starbase, Texas.
These are all of the team members that have helped build the vehicle, that have built the Pez dispenser, and got it ready to fly today. Amazing work.
Now, for those of you that have just recently tuned in, there is a spaceship in your screen, we promise. Right now, the ship is in orbital darkness, so we don't have any available sunlight from the sun to help illuminate the scene. But what you can see moving out from that smally lit space, those are the V3 satellites as they are being deployed. And essentially, the ship is illuminated from the inside, and so we're able to see the light come out through the payload door.
Right. Just a really small sliver of light at the top. That's our PEZ dispenser. That's how we're both loading our satellites into the rocket and deploying it. It's pretty novel. We've got about 3.5 minutes still left of our payload deploy sequence.
Yep, looks like we've got 16 satellites deployed, so 4 more to go. These last couple will have those cameras, so if you see any sudden bright lights, that'll be flashlights turning on those satellites to try and get some imagery of Starship's heat shield. 17 out the door. 3 more to go, and 18. All right, and while we wait for these last 2, we did confirm we are still go for our Raptor relight demonstration a little bit later in the flight today, so we will be looking to relight one of those Raptor engines on ship. And that'll be our next major milestone after we get through these final 2 satellites.
Just at 25 minutes into our flight, it's crazy to think that we're already screaming at 27,000 kilometers an hour, 200 kilometers above the ocean surface. Amazing.
Yeah. Now, for those of you that lost count, we have deployed almost all of our 20 Starlink satellites. I believe our last count was at 18, so we should be seeing 2 more. And we're very excited to see our version 3 satellites in space. And these are fully, these are real satellites. Right. They're not just demonstration sats like we had last time. These are going to basically have a 20-minute lifespan where our Starlink engineering team will attempt to perform a number of tests and really speed run those tests during that time.
Right. And in terms of satellite lifespans, 20 minutes is it's the shortest you could possibly get, but hopefully in that 20-minute time frame we can really try and ink out as many tests as we can.
It looks like we might have some, this might actually be light from one of the Starlink satellites. As we mentioned before, a few of them, 6 of them actually are equipped with flashlights to look back at Starship as we want to image the heat shield and understand the heat shield performance through the ascent phase, as this information is very important for us to know and understand as we prepare for operations that will enable ship to come back to Starbase for landing, for catch, I should say.
Right. And we are about 40 seconds away from that planned payload deployment sequence being complete.
Yep, looks like we've just got those last 2 to go. These ones might be coming out. Oops, they're starting to see motion. $19 out the door, 1 more.
It looks like we got a crowd at our Hawthorne, California location. Some colleagues gathering outside of mission control there as well.
And that marks, if I'm not mistaken, our 20th. So our payload deploy sequence is now complete. Starship will now close its payload bay door and continue to coast around Earth to the Indian Ocean. Still a lot of major events to come today, including our Raptor relight burn at T plus 38 minutes, 58 seconds, followed by atmospheric re-entry, where the heat shield will be put to test, and eventually our splashdown. So with that, we're gonna go ahead and go on to another quick coast.
Yeah, so sit tight, enjoy the views, and of course some more space jams, and we will come back here at T plus 37 minutes for our Raptor engine relight and of course Starship re-entry.
checkouts. DEC checkouts complete.
Welcome back once again to the Flight 13 webcast. If you're just joining us, our newest version of Starship, which you see there on your screen, successfully deployed 20 Starlink version 3 satellites. And I've got great news to share. Not only were we able to make contact with all 20, but we also made comms over lasers with all of them as well. So that is awesome. Hell yeah, shout out to our Starlink team. We're so thrilled.
Huge milestone. And that's only 3 minutes or 5 minutes after deploying them. I mean, that's crazy.
Amazing. And right now, we are expecting a relight of a single Raptor engine, and that's going to be coming up in just over a minute and a half from now.
That's right. We are going to be lighting one of our sea-level Raptor engines, and this is essentially just a demonstration that you can relight an engine after it's already done its ascent burn. And this is going to be really important when we do maneuvers for orbital missions, whether we're relighting to go into orbit, or if you're already in orbit and you're getting ready to do a deorbit burn. We did hear our Raptor team is go for the engine relight, so not going to be skipping it on this one. So we should see that coming up in just about 45 seconds from now. Again, this is not a deorbit burn for this ship. We are on a suborbital trajectory, so this Starship is coming back over the Indian Ocean no matter what. But this is going to be a pretty critical test for what we'll eventually need to do when we do orbital missions. When you got to relight those engines, do a burn to get yourself out of orbit. One thing that is unique on this one is we're going to be lighting it for a little bit longer of a time. We're expecting this burn to be up to about 14 seconds. We've only done about 3 seconds previously. And so that should be coming up within the next couple of seconds. Let's stand by.
Relight demo startup.
You see relight there on your screen.
Wow.
And confirmation over the net. Relight shutdown. The burn has ended. Congrats to the team on this milestone. I mean, it's crazy to see how we can maneuver in space, and just another icing on the cake for today's mission. So we're going to be taking another quick break. We'll be back in a couple of minutes before re-entry, which is targeted for about T plus 47 minutes. So we'll see you soon.
Vehicle and entry prep.
Starship is starting entry. Good attitude for entry.
Welcome back once again to Starship Flight 13, the second test flight of Starship version 3. As you can see by these pretty cool views on your screen, the ship is currently re-entering the Earth's atmosphere. Now, we probably have some first-time viewers tuning in today, so let's talk about this phase.
Right, so re-entry, it's a critical phase of flight, and we need information on how the ship's systems perform. So re-entry, you can see that speed in the bottom left-hand corner of your screen. We have to scrub all of that speed down so that way we can safely land. It's a lot of energy to be able to scrub down, and it's all the energy that we just used to launch the rocket as well. So Starlink will also help us gather as much data as possible, which is really the main reason why we do these flight tests, is to see how the ship performs in space and evaluate how it works. Starlink provides us with one more path to collect data to help us rapidly iterate Starship's design.
Yeah, exactly. And if the ship manages to again make it all the way through re-entry, we'll collect valuable data on the spacecraft flying through the Earth's atmosphere, and it's doing so at hypersonic speeds, or more than 5 times the speed of sound. Re-entry is typically a portion of flight where we don't have communications with spacecraft because it's re-entering at or around orbital velocity, which is roughly 8 kilometers per second or about 5 miles per second. So at those speeds, the spacecraft is moving through the atmosphere so fast that it creates a plasma field around the vehicle.
That blanket of plasma distorts communication frequencies, so it's not uncommon to experience brief blackouts in communication. Starship is designed to land on Mars, where there are no runways or other humans to help out, which is exactly why we're testing this landing procedure that we're doing today. And we're doing these propulsive landings instead of more traditional means like parachutes, because propulsive landing...
control of the vehicle.
You heard that call out, flaps do have control of the vehicle. You can actually see one view, your screen moving around. That's actually a camera affixed to the flap. So as I was saying, we're testing these, doing these landings instead of more traditional means, so that way propulsive landing, we can enable more rapid reusability.
Yeah. Now, we did just hear that call out. We should continue to hear some call outs as the ship makes its way back to Earth. Now, when we hear something called entry max heating, as well as entry max Q, that means that the ship has made it through the maximum heating and aerodynamic loads that it experiences as it returns. So, safe to say that if it makes it through those specific points, we're doing pretty well.
That's right. So we'll continue to hear multiple callouts as we go through this phase. One of those callouts will be that the ship is transonic. We'll also hear another one when it's subsonic. Transonic will be referring to the period of flight where velocities of airflow surrounding and flowing past the vehicle are concurrently below, at, and above the speed of sound, so somewhere in the range of Mach 0.8 to 1.2. For reference, commercial jets have a range of cruising speeds, but most fly at roughly Mach 0.74, 0.85. Just for reference, that's between 480 miles per hour to 575 miles per hour, or 770 to 930 kilometers an hour. And subsonic, another call out that you'll hear later on in the stream, subsonic will refer to speeds that are much less than the speed of sound. So at this point in flight, the ship's velocity will be slowing down drastically. So with reentry well underway, we'll take another break. and return just before the ship's landing burn, targeted for T plus 1 hour and 5 minutes.
Starship is leaving the peak heating phase of entry. External temperatures are coming down. Starship is at maximum entry dynamic pressure. Starship is executing the swoosh maneuver. Dynamic pressure is coming down.
Welcome back one last time to Starship Flight 13, the second flight of Starship version 3. As you can see on your screen with crisp views from Starlink, the ship is currently re-entering the Earth's atmosphere over the Indian Ocean. And really for the last several minutes, we had some amazing Technicolor views. It really looked like it was made out of starlight. Now, we did hear on the nets just moments ago that we made it through max heating and max dynamic pressure, meaning that the vehicle temperature and speeds and pressure are all coming down, and we can see that in the bottom left-hand corner of your screen as that speed continues to decelerate. We're coming up to the ship landing burn. One of pretty much everybody's favorite part of Starship test flight days, and that's going to be coming up here in just about a minute or so.
Yeah, just about a minute away. We're going to try and light all 3 Raptor sea level engines for this burn. We'll light 3, do the flip. We'll eventually go down to 2 as we get close down to the water, down mode to a final 1 engine before we hopefully execute a nice soft splashdown. We'll see if we've got our buoys and drones in range with the recovery team. They're going to be standing by to try and get some additional views of Starship's heat shield, which from kind of our initial looks, it did pretty well on the flight uphill, but we'll continue to dig through all the visual data as we get it. We didn't do any real stress tests or anything on this flight. We did do, you heard our landing Large flight controller call out. We were doing the swoosh maneuver. This is kind of the final maneuver that we plan to have Starships returning to Starbase do, that will essentially hook them out over the Gulf before coming in and over Tower 2. But about 10 seconds away, look for 3 Raptors, the 3 in the middle, to light up, do a flip. Let's see if we can get this thing in the water. levels lit. Seeing healthy chamber pressures on. Did our flip down to 2. Starship descending into the Indian Ocean. Down to 1. And we're in the water. And it's a soft splashdown in the water. That is a first. That is the softest splashdown we have ever had with the Starship there in the Indian Ocean.
It's bound to be an exciting day for our recovery team. I mean, that huge milestone to even get to soft splashdown, much less have the vehicle stay afloat.
Yeah, the teams are super hyped here. Got some crowd here at Starbase Texas. Everyone's super excited. We never really get to see Starship floating so serenely in the Indian Ocean, so we're certainly enjoying these extended views. Like I said, we're really pumped about this. I want to check in with Tyler. Tyler, how is Hawthorne feeling about Lucky Flight 13?
Hey, Kate, we are so excited about another successful Starship test flight and those gorgeous Starlink views that we had. And we can also confirm that we managed to make contact with all 20 of those V3 sats. So it's a massive day for us. So congratulations to everyone at the team at Starbase, for Starlink, everyone here and around the company who've contributed to the Starship program as we make progress again towards a multi-planetary future. So thank you everyone for tuning in. That's a goodbye from Hawthorne and back to you guys at Starbase.
Thanks so much, Tyler. Now, for anyone who perhaps missed the action, I suggest that you rewind the clock. Wow, look at that view of the Starship heat shield tiles. You can really see how the atmospheric re-entry, how it disperses the heat around the edge of the vehicle. I don't think we've seen quite that close before.
Never. And honestly, however short-lived that ship standing, bobbing in the water is, that is insane data for our team. It's unbelievable that we were able to keep that ship afloat. Now, we promised maximum excitement, and Starship V3 delivered. Congratulations to all of our teammates at SpaceX and to everyone who supported the Starship program. And thank you to all of our future customers for your support.
Yeah, as you could tell, the crowd really enjoyed that Nemo cam for a moment. We'd also like to thank the fine people of Cameron County, as well as the Coast Guard, the Federal Aviation Administration, and the Government of Mexico.
The amazing views do not end, so be sure to follow SpaceX on X for updates and more of these exciting shots that we didn't get to feature on today's broadcast.
And to get an inside real-time look at the teams bringing this incredible rocket to life, check out the latest episode of our documentary series, Starship. And of course, thanks to all of you for tuning in. And we're going to head back up to Dan for some additional thoughts.
Yeah, I'm losing my mind right now. We are still getting views from on board the ship with it in the water. Like, we had tried in the past to do these splashdowns as softly as possible. We experimented with rolls. This is the first time we've put an intact Starship in the water. This is a dream scenario for the team that's trying to get this heat shield data. Normally you're working with a slightly charred Starship in the water, and now we have one intact. So the recovery team is moving in with their drones, and we are still getting views from Starship. It is sending these via Starlink from the other side of the world while it is floating in the water after flying through space. Like, this is just completely surreal right now. This is just a mountain of data that we're going to get back. This is going to be so critical for refining the heat shield, everything else. And the really good news is all of these views that we're seeing, you're looking at a pretty intact looking heat shield, which, as a reminder, we were flying at a significantly higher dynamic pressure, so putting way more stress on this vehicle on the way uphill. And it's sitting there in the water, and I mean, look at it. So I'm a little bit over the moon on this. I know a lot of our team is just fascinated in the control room behind me. I mean, everybody is psyched. Everyone's gathered around their computers looking at these close-ups that we're getting of these heat shield tiles. 18,000 of them. I mean, you can probably count the ones that are missing right now on one hand. Like, this is just absolutely incredible. And the fact that, like, the cameras on board the ship are still sending back video is just a little bit surreal. So, wow. Lucky number 13. Hell of a flight for Starship. Get it all the way there in the water. Really great day for version 3. So, whew. All right. As Kate and Nate said, we're going to keep releasing more of this. Stay tuned. We've got some really cool stuff from some of the onboards that we caught, so keep following us on X at SpaceX. Whole bunch more cool imagery from launch, from the flight that's going to be coming out soon. Yeah, let's just close on that. I mean, look at Starship in the Indian Ocean. That's fantastic. We'll see you all back here for the next flight test of Starship version 3. With that, we'll say goodbye.